Welcome back, chemistry fans. Today we are going to try and go over the review for the dual enrollment final exam. So let's see what you would need to know about this. Let me share my screen and we can get started. Here we go. All right, so in this first question, we are asked to figure out the formula for a compound. You're going to need to know what these exponents, what these suffixes mean here, ITE. There are several different exponents. There's IDE, ATE, and ITE. The ATE and ITE are polyatomic ions, so that means it's either going to be NO3 or NO2 for nitrite. The more oxygen you have that ends with ATE, the lower amount that you end with ends with the suffix ITE. So barium is Ba, nitrite is NO2. It has a charge of -1. Barium has a charge of +2. You crisscross applesauce and you end up with your formula. Balanced reaction for combustion of methane. Methane is CH4. Combustion means it has oxygen. All combustions in with water or produce water and carbon dioxide. To balance this, we're going to need to put 2 of the hydrogens here to give us 4. That's over on the left. But now I've created a problem with my oxygens having 4, so I need to put a 2 right there. Physical properties are anything that changes that doesn't change the chemical formula. So we're talking about color, taste, smell. You could talk about sound if you wanted to, melting point, freezing point. Those do not change the substance. They're the same. It's just a temperature at which it is. You could then talk about ductility. You could talk about conductivity. Those are all materials. But then the chemical properties, those are ones that actually change the material. Those are reactivity. Those are combustibility and flammability. Okay. This number here in number 4, that is called the mass number. The mass number is equal to protons plus neutrons. So I will need to take 236 and subtract 92 to figure out how many neutrons there are. 236 minus 92 is 144. Metric conversion from picograms to teragrams. So right in the middle would be grams, 1, 2, 3. That would be our smallest. So that would be a millimeter, 1, 2, 3. And then we go to micro, 1, 2, 3. We go to nano, and then 1, 2, 3, we go to pico. And then 1, 2, 3, we come out here to kilo, 1, 2, 3. We go to mega, capital M, 1, 2, 3. We go to giga, 1, 2, 3, tera. All right, sig fig. So if we were to do 23.6 times 3.2, we should have only 2 sig figs. So in this answer, my final answer would be 76 with sig figs, because you have to round up then. If you were to add 3.21 plus 4.4, you would get 3.61, but our answer would be 3.6 because it's the number of sig figs after the decimal that matter. Just go with the lowest and you'll probably be fine for most of your efforts. Number 7 has been changed. There was concerns that it was not something that has to do with chemistry. So it has been changed. I am honestly not certain what it will change into. So we will fix that later. AMUs are atomic mass units. They are 1/12 the mass of a carbon atom. Empirical formula, 4 steps maybe, but 3 steps certainly. First step, turn percentages into grams. Second step, divide these masses, divide the new masses by their weights on the periodic table. 1.56, and 49.95 divided by 16 gives me 3.12. Divide both of these by the smallest. And what you get is 1 for the sulfur and 2 for the oxygens. Don't need to do the third step, which would be multiplied by 2. All right, percentage by mass of these. Aluminum weighs 27. Sulfur, there are 3 of them, weighs 32. And the oxygen, there are 9 of those. So we add up that total weight, 54 plus 32 times 3 plus 16 times 9. And we get a total of 294. But the question is percentage of oxygen. So 16 times 9 divided by 294, and you get 49%. So that'd be 144 divided by 294, and you get 49% oxygen. All right, number 11, mole map, convert grams into moles, or is it convert moles into grams? Moles into grams. So in the mole map, you are going to multiply by the mass of that compound. Magnesium weighs 24, nitrogens each weigh 14, and there are 6 oxygens. That's 148 times 0.75, and you get 111. All right, now we've got stoichiometry, 14 moles of O2. How many moles would produced? How much FeO2 is produced? Yeah, so here's our unknown. So we've got 14 divided by 3 times 2. That will give us moles, which is 9.3. What is the mass that is going to be in this stoichiometry problem? Again, 45 grams of this material here. It's out on the far left of the problem. So I'm going to rewrite it over here. So I've got 45 grams of this. And what is the mass of oxygen that is needed for this? So in these, there is an unwritten coefficient of 1 over here. I've got 5 carbons, 5 times 12, plus 12 more for the hydrogen. So I got 45 divided by 72 times 8 times 32. And that will give us the mass of oxygen, which is 160. So we just cross multiply, we substitute in the weight of the oxygens there. All right, so now on this one, I've given 2 starting materials. I've got 100 of this, and I have 110. No, I actually don't have 2 starting materials. What I want to figure out is the percent yield of SO3, it should say here, not of SO2. What's the percent yield of SO3? So here is my, the formula for percent yield is wrong over correct. So the 110 is the wrong value. I am looking for this X. So I'm going to take a unknown right here where I have the 110. So I'll have 100 over 2 times 64 is equal to X over 2 times 48 plus 32 is 80. So I've got 100 times 160 divided by 2 divided by 64. I should have made 125. So 125 goes underneath here, 110 divided by 125. And my percentage is 88%. Okay, so I've got a volume, I've got a pressure, and I've got a volume. That's a P1V1 problem. P1V1 equals P2V2. So I've got a balloon with 2.5 and a volume of 6. It changes to 1.4. What is my new pressure? It should say, what is my new pressure? So 2.5 times 6 divided by 1.4 is 10.7. This is stoichiometry with gases. So 5.6 moles of Ca 5.6. We are looking for the volume. Well, this is not actually stoichiometry. So this is just knowing that you multiply 5.6 times 22.4 because it's at STP. So 5.6 times 22.4 gives us 125 liters. Okay. Kinetic molecular theory, all material is moving. Collision theory says that they must hit to cause a reaction. What is the electron configuration for sulfur? 1s2, 2s2. By the way, sulfur is element number 16. 1s2, 2s2, 2p6, 3s2, 3p4. Just make sure that all the values equal up to be 16 on those exponents because those are the number of electrons. Sulfur has 16 electrons, so we're going to add that up. Which element has the largest atomic radius? It's francium, which is down here in the bottom left corner. The electronegativity chart for CO2. So what we've got here is if we look up the value for C, I will look that up. It would be provided to you on the test. Electronegativity chart. Carbon has a value of 2.5. Oxygen is 3.5. 2.5 and 3.5. So the difference between those two is 1. That difference is quite small. So it is, it's in between. So it's going to be polar covalent. And there will be a chart to help you rationalize that. But you might want to look up about what the electronegativity differences are. The formula for sodium carbonate, sodium is Na, carbonate is CO3. The charge is -2 + 1. You crisscross applesauce, so it ends up being Na2CO3. What two type of elements make up an ionic bond? A metal and a non-metal. How many electrons are present in this? Well, sulfur has 16, we just talked about. There are 4 oxygens, they each have 8, but what we need to recognize is that little tiny number there, the exponent -2 means you're adding 2 electrons. So 16 plus 32 plus 2 means that you've got 50 total electrons. All right, Hess's law in this problem, it again has the SO2 over on the left side, unfortunately. What we're trying to do is make this equal the gas and the solid over here, and this one is a solid over here. It's on the wrong side, so that means that the negative must become a positive. The gas is on the correct side, so it's okay. So we're just going to add those together. 618 plus 395, that's a -618, and you get -223 is your answer. How much heat is lost if we have 100 grams? So this is mass, specific heat, change of temperature, times 0.45 specific heat, 500 minus 28. The change in temperature is 472. Add all of this together, or multiply all this together, sorry, and you get 21,240 in joules is your answer. Definition of reduction is to gain electrons. To convert kilopascals into torr, what we have to do is first set up a ratio or set up a conversion. For every 101 kilopascals, there's 1 atmosphere. For every 1 atmosphere, there are 760 torr. So 560 times 760 divided by 101 is 4,214 torr. Oxidation number for sulfur in SO3, we must know that all oxygens are -2. That means that the total charge there is -6, so the charge of the sulfur must be +6. How many electrons are needed on the left side to balance this? If we look at the charges here, I've got +6 and 0 for the waters. I've got +14 on the left and -2. So I've got to make this all equal +6. So +14 -2 is a +12. How am I going to make 12 equal +6? I'm going to add 6 electrons to the left. which material is oxidized, which is reduced. All of the oxygens have a charge of -2. The hydrogens have a charge of +1. So it's down to the sulfurs, but the sulfur is doing both. So here it has a charge of +4. And over here, it has a charge of -2. But on the left side, it ends up with a 0. So which material is oxidized, which material is reduced? The sulfur is doing both jobs. But in this case, the sulfur is losing electrons. The SO2 sulfur is losing sorry. The H2S is losing, so that's oxidizing. And the other one, it is going to be reduced. The SO2 is going to be reduced. Which is the agent? Well, this is the exact same one. So if we can identify who is reduced, which it was the SO2, that means that it is the oxidizing agent. It's the opposite. All right, phase diagram for the Y. Just remember, here's solid, liquid, and gas. Here's your triple point. Here's your critical point. State of matter curve, heating curve, solid, liquid, gas. Whoops, solid, liquid, and gas. On the flat parts is where we have, oh my gosh. On the flat parts, that's where we have transitions like the melting and freezing or the evaporating condensing. All right, valid Lewis structure for SO3. So we need to be able to count valence electrons. 6 for all of these materials, that is sulfurs and oxygens. That's a total of 24. Plus there are 2 more because of the -2 charge. That's a total of 26. We'll do want minus have. There are 4 elements. They each want 8. That's a total of 32 minus the 26 gives us a difference of 6. Therefore, sulfur stays in the middle, oxygen on the side. We only have 6. It needs 2 extra electrons. All right, what volume of 6 molar would be needed if you're making 640 of a 2 molar solution? This is the same as before with the P1V1. This is M1V1 equals M2V2. So I've got 640 times 2 equals 6 times V. We don't know what that is. So 640 times 2 divided by 6 is 213 for your volume. All right. 70 grams of glucose, its weight is 180. So I'm going to take 70 divided by 180 to turn this into moles. And then we're going to figure out molarity as moles over liters. So 70 divided by 180 is 0.39 divided by 0.51 because we need this to be in liters. So my final molarity is 0.76. Lewis structure, geometry, and polarity for SO3. So doing the exact same thing we did before, I have 32 for the want. The have this time is only 24 because I don't have the 2 extras. That's a difference of 8. So how that makes this look this time is that I will have a double bond for one of the sulfurs, no extra electrons. This is trigonal planar, and it is nonpolar. 38, argon. It's in a flask, and it's got all of these values: volume, temperature, pressure. That's PV equals nRT. So the pressure is 620. The volume is 6. The N is what we're solving for. The R is 62.3. The T that we're looking for, it has to be in Kelvin, so that's 283, and that's trigonal planar. So I can write that down. All right, so now I'm solving for the N. 620 times 6 divided by 62.3 divided by 283, and I get 0.21, number of moles. Mass, so I convert moles into grams. The weight of argon is 40, so I'll take those number of moles, multiply it by 40, and you get the mass is 8.4 grams. Balance the following reaction. Leave please leave the polyatomics together take this water and split it up, and it'll make your life easier. I will put a 3 right here because there are 3 sulfates. I've got 6 hydrogens, so I need to put a 6 right there for the hydrogens. I've got 3 of these hydroxides, so I need to make this a 2. That will also change my ASs to 2, which is what I need. So now this is balanced. Full electron configuration for silver. Silver's element number 47. So I'm going to do 1s2, 2s2, 2p6, 3s2, 3p6. 4s2, 3d10, 4s2, 4p6, 5s2, 4d9. That's your 47. Name these compounds. This is pentacarbon heptafluoride, IDE. The polyatomics on this one are ammonium carbonate. And then the last one, we have a transition metal. Phosphorus has a charge of -3. There are 2 of them. That means it has a total charge of 6. So the chromium must have a charge of +6. So its Roman numeral will be Vi. So the name of that one is chromium 6 phosphide. Predict the products. This is a double replacement. So I am going to switch places with these 2 materials. So I'm going to end up with sodium nitrate and calcium sulfate. Now those are already balanced, both of those, because this is +1, -1, +2, -2, but the reaction is not, so I need to put a 2 in front there. Now next is a stoichiometry problem. 39 grams of water. How many grams of sodium hydroxide? So we'll put 39 over 3 times 18. The weight of water equals X over the weight of chromium is 52. 52 plus 16 plus 48 plus 3 is 103. So cross multiply 39 times 103 divided by 3 divided by 18, and you get 74 grams. Almost done. Hold it together. We're almost out of here. 44 molecular formula. So this is an empirical formula to start off with. First step, convert these into grams. So I've got to divide this by the weight of phosphorus, divide this by the weight of bromine. 7.19 divided by 31 is 0.23, 92.8. 1 divided by 79.9 for bromine is 1.16. Now divide these by the smallest. That equals 1. And this equals 5. Don't need to multiply it by 2, so it ends up being PBr5 is your answer. Balance the following redox reaction. Oh my goodness. So what I need to do is find some space actually out here. So I'm going to separate this into 2 parts. And then CrO3 minus 1 produces CrO4 minus 1. Okay, I'm going to balance first off the oxygens on the Mn. So that means I need to add 2 waters, but then that means I need to add 4 hydrogens. Now to balance the charges of these, they're both equal to 0 so far. So I need to add 4 electrons over here. Down below, I only need to add 1 water. But that means I need to add 2 hydrogens over here. Whoops, 2 hydrogens over here. Now my charges are now equal. My electrons are not equal, so I'll multiply everything by 2. That means the electrons are going to cancel out. This means my waters are actually going to cancel out, as well as my hydrogens. So my final answer actually becomes something very, very simple. It just becomes what it was written as. Let's see here. 2 waters, 2 waters. Something's not right. Just add those together and you get your final answer. I will double check that to make sure that things are working out correctly there. That doesn't seem 4. So there's something missing with the charges. We're gonna have to deal with it, and that's gonna have to be as good as it gets. There's something else off about that one, but we'll figure it out. Okay, Hess's law. So we're gonna look here and see that B2H6 is on the correct side. That means this is okay. The 6 CLs. So I've got CLs right there that are all okay, but they're 1/2. So that means I need to multiply all of this by 12 to make sure that I get the 6 CLs. So now we're okay with that. Now we can go with the BCL. Where is it at? BCL3. It's on the wrong side. It's on the wrong side. So I need to flip the BCL and multiply this by 2. So that's going to become a positive, and it needs to multiply by 2. We get our final answer by summing all of that together, 112.5 times 2, and that is a positive, minus 493.4 minus 12 times 92.3, and I get negative 1376. All right, last question. Final temperature, specific heat of benzene. Let's see. So I've got heat in equals heat out. So I got 45.6. Specific heat is 0.45. It is heated to 83 degrees. So we don't know that temperature. I put it in 50 grams of benzene, and it has a final temperature of 32 with specific heat of benzene. Oh, so we do know all this. Okay, so it has a final temperature of 32. So the difference in the temperature, if it starts at 83 and it ends at 32, means it had a temperature change of 51. It lost final minus initial. 50, we don't know the specific heat of benzene. We know its temperature, 22, it ended at 32, so it went up 10 degrees. All right, so we're just solving here. So 45.6 times 0.45 times 51 is 1046.52 negative equals negative 500 CP. Divide both sides by 500 negative. And you end up with specific heat of benzene of 2.1. All right, this is everything that we need to know to help us for this test. Thank you so much for everything that you have studied for this year, and I hope that you do very well. Don't worry, we will make certain that this is a non-consequential test and that your earned grades are what they stay and reflected, and we're only going to see positive scores. So come and ask me questions if you need help. We'll talk again. Bye-bye.